Hello, everyone, and welcome to today's webinar, Testing on a Lean Diet. Thanks for joining in. My name is Divya Sharma, and I'll be your moderator. I work with the marketing team here at QA InfoTech, and I'm excited to be hosting this session today. Before handing over the mic to our speaker today, I have a few items to cover about this presentation. To start with, a recording of today's webinar will be made available after the live session. Also, we'd love to hear from you during today's presentation. So if you have any questions for our speaker, please feel free to type them into the question box on your GoToWebinar control panel, and we'll take them up at the end of the presentation. Moving on, I am pleased to introduce today's speaker, Ramandeep Singh. Ramandeep heads Test Automation and Research Lab and has presented many webinars. And today, he's going to highlight the credibility and expertise on mocking the data to test front-end functionality of an application and virtualize the services to remove integration. Without further ado, let's get started by welcoming our speaker, Ramandeep Singh. Ramandeep, over to you.
Thank you, Divya. Before we begin, let me also add to my intro that I don't just head the Test Automation and Research Lab here at QA InfoTech, but I am an active practitioner and hands-on tester, test automation engineer, coder, trainer, tech talker, and striving to be way more than that. So before we begin, once again, very warm welcome to all our attendees, the audience and listeners today. This webinar presentation is another one in line of all the webinars that we have done in the past on various topics of testing, be it test automation, artificial intelligence, accessibility, localization, mobile testing, and all. So I hope that even from this webinar presentation, all of you would find some takeaways which you can implement or try out within your projects, and hope you find this interesting. Like the topic suggests today, testing on a lean diet, the focus of this webinar session is essentially on test automation, primarily on making overall automated tests more effective, such that we get more return on the investment and reduce the unnecessary overheads and overloads in test automation, be it the development and or the maintenance of the automated tests. Now, I do recall that, nowadays we heavily rely on automated tests and test results, specifically when it comes to regression testing, and test coverage needed from automated tests. But there was a time, almost like a decade ago, when we definitely were trying out a hands-on test automation, and but the reliance on the test automation and results were really small. To a level that we were only doing automated smoke or sanity tests, and were at that moment trying to expand to other test suites and essentially provide more coverage through automated tests. But then, as the technology, as our knowledge in test automation, as the skill set and the resources evolved over a period of time, we gain more sophistication and experience in building automated test solutions. And overall, the industry, as well as at QA InfoTech, we were able to build automation solutions which have not just become just a supplementary part in testing cycle, but have essentially become an essential part in the overall quality engineering of a product. So, although that compared to a few years ago, the reliance on automated tests and test automation is huge within quality engineering and testing cycles nowadays, but you would still find and agree to the fact that there still is a question mark on the effectiveness and total reliance of needed test coverage on just automated tests. I mean, you would still find some amount of flakiness or ineffective tests or tests that are unreliable, which we still on a daily basis are dealing with when we're dealing with the projects in which we're doing test automation. And to that level, let me start the discussion with talking about a trend of coverage and effectiveness in automated tests that we have observed within QA InfoTech in all the projects, in most of the projects in which we do test automation, as well as we've seen a similar trend and pattern out there in the industry as well. So this is how it looks like. Assume that there's a product where you have about 100 tests, and you want to do test automation, you want to provide the regression test or test coverage using automated tests. Now, on an average, 70% is what we target to do with test automation. 70% is the desired test coverage that we try to do with test automation, so that we have a good return on investment that we do in building the automated tests. Now, this number, I've taken it as 70%. It may be more or less depending on the kind and circumstances the product is going through and the technology available within the product itself to be able to automate all its possible cases. I mean, you can definitely find outliers where there are products where you can do up to 95 to 100% test automation, but they are rare occurrences. But if you look at it on an average, 70% is what we're looking at in most of the products and developments. So let's say that the test automation or the quality engineering team targets 70% or 70 tests out of 100 for test automation, and they invest time and resources to develop the automated test suite. But when it comes down to execution of those tests and to draw the necessary outcomes from those tests itself, we usually figure out that only about 50% of the overall the complete test suite is actually reliable and works as expected, or the test behaves as expected, and the remaining tests are flaky or not reliable when they throw out the results. And when I say they behave as expected, it doesn't mean that they pass always. Rather, if there's a defect in the application, these tests fail and report the defect properly. And if there are no problems in the feature, these tests pass and report that the feature is working fine properly. Whereas the flaky tests are the ones, or the unreliable tests are the ones which intermittently fail, and when they fail, they do not report the problem properly as to whether it is a problem with the application in the function, or whether it's a problem within the test or within all the circumstances under which the test was executed. Now, there can be various different reasons why the test is flaky. We would be talking about those various reasons as we go ahead in the presentation. But for the trend's sake, what we have observed is that about 10 to 20% of the overall tests that we have in the product are ones that are flaky. Now, these are not the same tests every time. I mean, the tests change build by build and release by release as we keep executing the automated tests. But that's the number that you can safely quote if you look at the average line among all the tests that you have seen. Now, this is the pattern that we have observed in most of the projects where we're doing test automation. The numbers may not always be accurate, such that you can say that these numbers is applicable to all the products and all the projects, but you would certainly be able to relate to this pattern of the trend and pattern of the results that are coming out from automation the automated tests and automation, the automated tests and the results. Now, let us, when we move on to the other parts of the presentation, let us try and understand what are the reasons for these tests to be flaky and what can we do to make sure that even these flaky and unreliable tests, or the uncovered area that we have in our overall required test coverage, what can we do to even provide coverage, and that to reliable test automation coverage to this uncovered area? So in order to understand what are those reasons that make tests and automated tests unreliable or flaky or not behave as expected, let us try and understand this through an example. Let's take a case of an online shopping store. And when I talk about online shopping store, what better than talking about the giant Amazon itself? So this is the Amazon, local Amazon India site. And now there's one very interesting feature that we see in most of the marketplaces, e-commerce sites online, which is the wish list. Now, as a user of this portal, I can create multiple wish lists by browsing through products and adding them to my wish list. And whenever I'm ready to buy those items sometime in the future, I don't have to search those items again. All I can do is come back to this page and open my wish list and select an item from my wish list, add it to cart, and check out from there. So that reduces my overall time of finding the product and checking it out, because the product is essentially maintained in a wish list. Now, imagine that there's a test that we have to perform, and the objective of the test is that when we to check whether we can add a product from our wish list, from a user's wish list, to the shopping cart and do the checkout process from there on out, whether the checkout and the shopping cart behavior works properly when we add the product from a wish list or not. So in order to perform this test, we built an automated test around it. Obviously, because this is a UI test and it has to work inside the browser, we use Selenium to perform and execute the test. So let's assume, this is one of the examples of this automated test that we're talking about. If you look at the automated test, it uses pretty usual and familiar language of test automation, which is, in this case, it's Java, but essentially underneath it, it's using a domain-specific language or a DSL built on top of page object pattern in Selenium. That's a standard Selenium-based test automation technique that we frequently use. So you can see the flow of tests within this script. Now, there are many problems with this script, but let's focus on, at this moment, the flow of the script. The first item is login, where we're logging in with a particular username. Then we are adding the item to wish list. So we are searching for an item by a certain keyword, and then whatever result that we get, we're trying to add the first result to excuse me, to the wish list. And then we're going to the wish list and adding getting the item from the wish list and adding it into the shopping cart, and then completing the checkout procedure from the shopping cart by going straight away to the shopping cart. Now, there are two ways in which we can implement this test case. One is where the item that should be available in the wish list for me to complete this test case, I can actually bake it in as part of the account that I'm using here. So imagine that there's one account which I use in order to execute this test, and that account would always have a wish list, and that wish list would always have one particular item available at the very top of that wish list. So if I want to run this test, I'll always use that particular account to log in into the application and then proceed with the test. so that I always find the item in the wish list. That's one way of doing building this test, where we are relying on the data, availability of data, which is an account with the specific settings in there. And the other way is the way I've shown it in this script, where as we log in, I'm building that prerequisite for the test as part of the steps of the test, where I'm adding an item, for finding and adding an item in the cart, and then proceeding with the actual test steps, where I go into the wish list and then I, I'm sorry, I add the item from wish list to shopping cart, and then follow with the checkout process in the shopping cart. Now there are multiple problems with both these approaches of implementing these test cases, and the problems are that in both the cases, in one point or the other, the test automation objective relies on the prerequisites, which is the dependency or availability of data. Now, as you know, when we are doing testing, we don't actually always do testing on the production environment or against the production data. When we are in development, active development, the actual testing that happens in the life cycle, in the pre-release life cycle, is in the lower layers. It could be a dev environment, it could be a excuse me, it could be a local environment, it could be a pre-release, a QA environment, and the availability of data is absolutely questionable there. You cannot be sure that you would have the exact same data that is available on production. That means that you actually heavily rely on the data that is available on those environments in order for this test to be executed. That means if you have multiple environments and you want to make sure that this test runs on multiple environments, you need to make sure that the data that is required by this test needs to be available on all those requirements. And what is that data? An account with the wish list, or the product available by this name and searchable through this query, NFL jersey. Or we need to parameterize this data and make sure that we have test data available for each of the environments where we want to run the test on. So essentially, you can clearly identify the problem here that if you have multiple environments, multiple builds on which this test has to be executed, it relies on so many other factors which are not directly related to the test objective, but because that's a prerequisite requirement of the application to be able to attain a base state, it becomes a dependency of the test itself. Now let me show you a demo of an alternate implementation of the same test. Let me execute that test first, and then we can talk about what's happening inside this test. So let me run this test. And you would see that a browser has come up. It has started Amazon and it is trying to now log in using an account. And once it has logged in, it would go into the wish list page where there are items already available in wish list. And then I select the first item and then add that item to the cart, and then proceed with the remaining steps in the workflow where I go into the shopping cart and make sure that the item that was there in the wish list is now also available in the shopping cart, and I compare the attributes of the product, the price and everything is the same both in the wish list as well as in the shopping cart, and then I proceed with the remaining assertion and validation steps of the product. So what I'm doing different here is that through a technique that we very frequently use nowadays, which is service virtualization, I am mocking or stubbing out the data that is provided to the application through one of the service calls, which is get wishlist in this case, such that I always get back the data from the service which I expect in my test. So rather than having a step within the application with which I create a wish list as part of the test, or rather than making an account which would always have the test data, a wish list available within the account whenever I execute the test on this environment, what I'm doing is I'm virtualizing one of the services so that whenever the front end application makes a call to this service, that call doesn't go to the actual server at all. Rather, the response comes back from what I have coded in my test so that I can control the environment and control the data that is coming into the feature that I'm trying to test. And then from there onwards, I'm in total control of the environment because I have given the feature the data that I was expecting, which is the wish list and the exact product that I expect to be there in the wish list at the very top. So we'll further talk about how we're doing this by looking at some pieces of code later in the presentation. But let's further look at the problems, such similar problems that we have just identified, and a couple more problems that we see which cause tests to be rendered ineffective or flaky or unreliable. So what are the things that tests stumble upon when it comes to effectiveness of the test? Well, when we are doing end-to-end test automation and when we are relying heavily on tests that are written and authored from an end user's perspective, these tests are workflow dependent. And by workflow, what I mean is, one example was just that we saw where if I need to go to a wish list and check out an item from the wish list itself, the application has to be at a certain state, and that certain state is the application needs to be logged in, and it needs to be logged in with an account which has items in the wish list. So there are certain states that the application needs to attain before I can continue the workflow, I can continue the test and do the remaining assertions of the test. Now, this is the workflow dependency that such tests would have. They depend on factors which although we cannot control much because they are essential part of the application, but then we don't want them as part of the application because we're not testing that, they're not part of the test scope. Rather, what is in the test scope has, in order to reach to that point, we need to follow that whole workflow in order to attain the application to a state where then we can start our test, or a state what we can call it as a base state. Similarly, the test also has a lot of data dependency. Now, as we have seen in this example itself, it depends on so many different test data like the account, the credentials that I'm using in order to log in. Now, every different environment in which this test has to be executed, it would require the account which works specifically on that environment. Now, a QA environment would be pointing to a QA database and may require a credential of an account which is there in the QA database. A test in the dev environment may require a credential from the dev database. So even the data that the test is depend on changes depending on the environment and depending on the situation of the application. And because of that, there are huge problems because there are so many factors that the tests depend on, yet it's really difficult for us to, in an automated way, control those through automation. And on top of that, the applications that we are testing also have integrations which go beyond just the integrations, the scope of development within our development team itself. For instance, imagine that there's a learning management system that we are testing, and the test objective is to check whether the gradebook is able to add the grades of a student properly when he's trying to attempt a test. So now the problem there is that if I build a test which would go in as a student in the LMS, launch an assignment, start taking the assignment quiz by answering each of the questions, and at the end go into the grade book and look at the grades. Now, as part of my test, the I need to build in the data such that whatever question comes in the quiz, I need to know the correct answer of that question. Now, if it's a multiple choice question, and you know that the way questionnaire works nowadays, you every time you start the assignment, it won't be the same question that comes in. It would every time it would be a random question that comes in, and without reading the question and understanding the context, you won't be able to figure out what is the correct answer for the question. So either you have a way to figure out the answer key for each of the questions available in the database, which again is not possible for mere doing testing and test automation, or you find a way to make sure that every time whatever option you correct, that becomes the right answer. So that's where the problem is, where your test, even if you build this test, the test depends on availability of test data and availability of possible integration with the quiz and questionnaire service as well as the gradebook service. And also not just the integration of these various components, whether they are first party or third party, but also on the performance of the latency and the performance of these services. Now, my test could be as fast as the application is. If the application depends on third-party components and these third-party components are slow, then my test is going to run slow. Now, because of all these reasons and all these factors that the tests have to go through, the tests hence are slow, they are brittle in nature because they depend on so many factors which we're not able to control properly within our automated test. And hence, even if we are able to build the test, some of the tests are really hard to diagnose because when the test fails, it throws out the results which requires deep down introspection to figure out what exactly went wrong in the application or in this particular case, whether the failure was because of a problem in the application or because of a dependent test data not correct or a dependent service not behaving properly. So how do we solve this situation and such flakiness in the automated test? Well, the best way is to split the test into smaller, discrete tests, such that each of those tests can be executed very rapidly, independently, without any dependency or relying on workflow or a lot of test data. And the tests having clear and defined and focused objectives, so that whenever there is a failure, by just looking at the test report, we can directly point out what the test was, what went wrong, whether it is a flaky test, whether it was a false failure, or whether there's something really wrong in the application, so that the overall debugging and reporting can be enhanced further. But how do we achieve all these things that we have identified within the automation? How do we actually do these things? Well, first and foremost, it's about how you define your test. The definition of the test has to be in accordance to the objective of the test. And for that matter, we have various means available to define the test and build the test or the test description in a very collaborative fashion. I mean, we have been talking and practicing using behavior-driven development, where we're using Cucumber and other specification by example frameworks like Mocha, RSpec, Spark, SpecFlow, and a bunch of other similar JBehave and a bunch of other similar frameworks where they allow us to create and author the tests or scenarios in such a way that they are collaborative, that anybody who is the participant in the development of the product, be it a tester, a developer, a system analyst, a product owner. They can contribute into enhancing, adding, authoring, and creating new tests and scenarios. And because the tests are written in very English-like business language and not in technical language, anybody can understand those tests and easily comprehend them and contribute into overall quality of the product by enhancing the quality of the test. And then because already frameworks are available to quickly convert them into automated tests, the automation also gets an effectiveness push from that. And we have been talking about domain-specific language for a very long time, where rather than building a strict, tight function library, we build a function library such that it is in context with the kind of application we are trying to test. For instance, if it's an e-commerce application, I would have functions in there in my domain-specific language, which would allow me to perform tasks, which would provide me an API to perform tasks in the application. Like in an e-commerce application, the task could be register as a user, log in as a user, find product by keyword, find product by ID, quick buy product, add product to shopping cart, check out with credit card, check out with gift card. So these are the major keywords that would be applicable if it's a DSL of an e-commerce application. And similarly, if it's a different domain application, the DSL has to be designed accordingly. Now, these two things essentially give an expressiveness to the test, both in terms of the language of the test as well as the function library or the code of the test. And when it comes to making the test expressive, it essentially makes them really easy to comprehend as well as really easy to maintain and build for a longer running automation solution. Now, here's an example of Cucumber test, and you can see a number of things that are definitely very wrong in this example. Now, when we talk about Cucumber, we always try to make sure that the scenario definition in Cucumber is free from any form of technical and structural detail or implementation detail of the application. The scenario that we write should be free from the influence of how the feature or the behavior would be implemented in the actual application, because one feature or one behavior can have multiple implementations. It's totally up to the creativity of the user experience designer if it's a UI behavior, or the feature designer if it's otherwise, to decide what is the best implementation of this feature. But in Cucumber, all we need to do is make sure that we have a scenario, an actual example of the scenario with which we can define how the behavior would look like when an end user would exercise that. And if we are introducing or adding technical details within the documentation of Cucumber itself, like in this particular case, we are mentioning things like XPath and wait for statements. So all these things, essentially, if we add such things, not everybody within the group would be able to comprehend such language in Cucumber, and it would be really difficult to maintain them on a long run. Especially when the application is undergoing frequent changes because we are trying to enhance the user experience of the application, the implementation of the front end is going to change a lot over a period of time. And if that changes, we'll have to change the definition of this test case once again based on the new implementation. Instead, the same Cucumber scenario can be written somewhat in this way, where what we're doing here is that we have stripped down all the implementation and technical details from the scenario. Rather, we now have the scenario defined in a much neater way. We are establishing the background or the prerequisite state by the given statement, and then when we are defining what are the actions or tasks that the user is performing or the actor is performing in this case, and by then we are defining how do you validate the outcome of the system. or what are the expectations from the system. And so that is one way that you focus more on the definition of the test and how you essentially define the test. But the second most interesting part, or the second real solution, lies in interception and mocking. We essentially need to virtualize the services which are acting as a dependency for one workflow which we have to test. For example, let me actually open the code for the yeah. So this is the Amazon test that I executed in the beginning, and what I'm doing here is, instead of if you look at this piece of code, instead of either building a wish list before the test is executed as part of the test steps, and then using that newly created wish list to execute the test, or rather using a test account which always has a wish list, what I'm doing is I am mocking the response of the wishlist service such that when this test is executed, the response that comes to the front end for the wishlist that is rendered on the screen is what I have provided as part of my data. So you can see that what I'm doing here is I have a function call here which says mock wishlist, where I'm providing a fixture of the wishlist response. And in this wishlist response, I have specifically defined which product would come on the top. Now I can easily change this account to any other account, the environment to any other environment of Amazon, and run the same test. Now, with whichever account I run with, whichever environment I run with, whenever I go to the wishlist page, I would always see the product that I have added in my fixture in the wishlist in Amazon. Because what I'm doing is, there's a dependency on the wishlist service. I've created a virtual service, and the application now, rather than going directly to the actual service, is actually going to the virtual service and getting the response from there. And that virtual service is built within the code of the automation itself. So that's essentially how we are achieving virtualization as one of the examples. Now, with virtualization, we're not just deciding what should be the response of the service, but we're also deciding what is the data that the service responds with. So we essentially are we essentially have, with a way of virtualization, a way to bake the test data that we require, so that whatever dependency that a test may have, whether it's dependency on the data, whether it's dependency on a service, that can be resolved by virtualizing all those dependencies, so that the test is strictly focused on the test objective and not on building and handling all these dependencies before the test actually begins. Now, there are various ways in which you can virtualize services. There are so many frameworks and so many tools and utilities available out there: Sign-on.js, Pact, Mockito. What I'm using within my example is an API of the browser itself to get the browser debug toolbar available, and then perform and then intercept the service, and then reply with my own response within the service. Now, a very similar example is Fundo Player. Now, what we're doing, now this is a small player which can be embedded. It's an HTML5 player which embeds a video, and then it has the features where, I mean, you can look at the video stream in various bit rates, and it has an adaptive bitrate feature where, depending on the bandwidth that is available on the platform, it the front-end player automatically adjusts the desired bitrate of the video, so that you don't see any jittery or any unnecessary loading on the player. Rather, you always see a smooth video playback. But if we have to test this, how do we actually test this? There are two things that we'll have to control if I want to test this in an automated fashion. One is the bandwidth of the environment in which this test is executed, so that I can keep throttling the bandwidth to the point where it would try and switch the bit rate. And when the player switches the bit rate, I need a way to check what bit rate chunk is the player trying to get. That is exactly what my second demo is, where we have built a test using both interception and virtualization in such a way that I'm able to, we have built a virtual environment where we are embedding the plane. Now this is happening in headless mode. You won't see anything happening. What is happening is that there's a VM that is running on this machine, and it's a headless VM, and the player is embedded in a headless Chrome inside the VM. And what we're doing is, through an automated function call, we are controlling the bandwidth. And with every rerun of the test, we are changing the bandwidth to a little lower level. And then we are comparing that what is the bandwidth of the chunk that the player is trying to download, and what is the bandwidth that we have set as the bandwidth of the environment in which the Chrome is running. And then we are comparing those two and making sure that we're doing the validation that the player automatically is switching to a lower bandwidth, or the correct bandwidth that matches the available bandwidth of the environment. You can see that at a higher bandwidth, at about 1000 kbps or 700 kbps, 400 kbps, the player is trying to download a bigger ID or bigger screen size of the video, and hence a bigger bit rate. But when the bandwidth goes below 100 kbps or near about 100 kbps, that's the bandwidth cap, and the player is trying to download a video of a smaller bit rate. Now, the next thing, obviously, virtualization is a huge thing that has to be done in order to reduce all the dependencies, be it the data dependency as well as the service continuity service dependency within the automated test. But once you have virtualization mocking of services in place, you can reduce your overall test solution in a huge way. Now we have been building huge frameworks which are self-contained in such a way that they have functions and capabilities available to perform almost everything that is required within the test execution, be it controlling the environment, controlling the test data, and reporting and all of that. But with smaller tests in picture, we're trying to build smaller tests. We're trying to reduce the test dependency by introducing things like virtualization. We don't actually need bulky frameworks to do too many things for us. Rather, what we need is smaller minimalistic frameworks, and anything else that is needed as a capability can be added in as a service. Now, we've already seen the test automation industry grow in such a way that there are so many services out there which can be solutions that are available as service out there, which can be utilized rather than building those capabilities as part of our framework. And mocking stubbing definitely has to be done versus trying to manage and create and build and provide test data as part of the automation solution. So wherever you have huge test data, look for ways to do mocking and stubbing so that that dependency of the data can be removed. Now there are a bunch of other techniques that can be taken within the automation test, like retrying fail test. Now that's one feature that kind of comes in built in almost all test frameworks, be it Cucumber, Mocha, RSpec, and now also on TestNG. So we should definitely try all these things. So to end and to conclude, there's a definite need to make your tests smaller and leaner so that they are free from all unnecessary dependencies and run faster. And if they have to fail, they fail fast so that we have enough opportunity to go back, analyze those fast failures, and then update them and rerun them as needed so that they are more effective. The tests have to be green. They have to be reliable in such a way that whenever they fail for the right reasons, and they report they're accurate in reporting whatever is the problem in the application rather than reporting the problems in the test script itself. And the tests have to return the value that has been invested in building these automated tests. So they have to be mean enough so that the objective of the test is correct, and whenever the test is executed, it is giving us the right results. And all of these things are only possible if we are able to reduce or split the test, bigger end-to-end tests into smaller, discrete, independent tests, which can be executed, which may fail fast, but in which we are able to handle all the dependencies using techniques like virtualization, mocking, and then we have ways to run these tests in parallel so that we can actually get results early and then get the value that we desire from them. With this, okay, so that's the end of the talk, but over to all the questions. I hope you have already entered all your questions that you may have in the chat and the question section. What we'll do now is we'll go through these questions and try and answer them as many as possible in whatever time that we have. Okay. So here we have a question. It says, wouldn't testing in DevOps solve? Okay, the question is, wouldn't testing in DevOps solve these problems? How is this different from DevOps? So I believe what we mean is continuous CD rather than DevOps, CI and CD rather than DevOps. Yes, essentially, all these techniques that I have demonstrated today, they kind of are very effectively used even in CI and CD and in automation that we're doing in hyperagile and DevOps development models. But the problem is that you don't always are in control of the environment of the application, the complete environment of the application. At places where you are able to do CD, CI, and DevOps, it's really easy for you to control the application and its state and environment. There, you would definitely be already doing all these things, but places where you're dealing with legacy applications or applications that do not allow you to virtualize or deploy the application in containers, things like ETLs, things like legacy features and components, things like with application depending on so many other factors. There we still need to find ways to do virtualization so that containerization is not the only way to deal with virtualization. So yes, if you are doing CD DevOps, you would already be doing a lot of these things. But for all the other applications where at this moment CD and DevOps is not possible, we definitely need to look at these techniques. Okay, next question. How does this work with my regression tests? That's an interesting question. Well, you'll have to refactor. You'll have to do a lot of refactoring within the tests. I mean, and be prepared to let go of some of your development. I mean, there's a call that the team would constantly have to take whether they want to rebuild the whole test again, or they want to modify and update the test so that it fits the newer implementation of the application as well as the newer things that we have learned over a period of time. So yes, refactoring has to be done with the regression test suite to make sure that the tests are now small enough so that the dependencies can be handled through virtualization, and then so essentially you need to split, divide, and conquer. I'm sure if you're talking about legacy regression test automation, we used to do test automation end to end so that we used to build longer workflows and tie them together into single um, automated test scripts. So we definitely have to figure out a better way of redefining, rewriting those tests into smaller discrete tests, independent tests, and then using virtualization and other means to fulfill the dependencies that they may have. How do you do it in a Selenium test? Well, the example that I've shown you was the first example that I've shown you where we're doing it in Amazon was actually using Selenium in order to exercise the application. Now, in that particular case, I was not using PACT or WireMock or any of the HTTP or service mocking framework. Rather, what I was doing was I was using the browser's debugging API to intercept the outgoing HTTP call and then send in the data that I want to it. Now, this can also be achieved by other means like using Fiddler alongside your Selenium test, or using proxy and then controlling the proxy or Fiddler through your automated test. Which is a very common practice which we follow when we are testing mobile apps, the Android and iOS apps. So when we require virtualization of services within them, we end up using either proxies or things like Fiddler. Okay, I think that's the end. So over to Divya for the closure.
Thanks, Ramandeep, and thank you, everyone. We really appreciate you being here today. We'll share the recording of today's session shortly. Thanks again for joining us, and we will see you next time.